Next, we're coming on to the theme of climate change, although we're already there, of course, in everything we talk about in these conversations. We're going to have a panel on it. But first, I'd like to just introduce a short segment from Antje Boetius. We're going to hear from her twice in just very short pre-recorded videos. Like Maud Barlow, Antje isn't available this weekend to join us online, but I did speak to her a couple of days ago and had collected some of her thoughts on climate change. She is the director of the Alfred Wegener Center for Marine and Polar Research in Germany. Spends a lot of time at the poles, and here, once everything is put out, we will see her thoughts on climate change.
The problem with what we call climate change is that we are experiencing already now at a global warming of 1.2 degrees on average, extremes that have not been observed before, extremes in patterns when it comes to rain, when it comes to drought, when it comes to floods and more, that are not known by people, where our infrastructures, be it that we are from highly developed countries or not, we haven't seen it. It costs lives, it creates damages, and it's only 1.2. And we're moving fastly towards 1.5 degrees. So the speed of change and the extremes that we are facing are, to me, the most worrisome effects on society today. Of course, in human history, we have knowledge of extremes, but we are a high-tech society in many places, in other places even more vulnerable because there's so many people affected. Just look at this year's catastrophes in Pakistan, for example, but also last year's in Germany. So no matter where you turn, you will find observations that say this is 1 in 1,000 years. But we know it's not a stochastic event to parts that we can even model and simulate. It is us, humans, that are on the wrong track with regards to the use of fossil fuels and still are on the wrong track despite all the really good political goals. When we look around us, it is clear that droughts cause an absence of water, and that creates a pressure on people's lives because humans need water. We cannot go very long without clean water, and there is not enough access to clean water on Earth. When we go to the polar regions, we observe water in a different form, in the form of ice. There's sea ice, there is the ice masses on land, Greenland, for example, and Antarctica, and there's the frozen soil with snow on top. And all of that whiteness of Earth that reflects the sunlight, we call that albedo, is a critical shield, a climate buffer, a buffer against overheating. And this buffers against the sunlight that wants to warm the darker surfaces like rocks and ocean. Where the sea ice is melting away and the dark ocean comes out, the sun will warm the ocean water more and the ocean will start melting the ice from beneath. It also, the same process can be observed around the shelf ice of Antarctica and also Greenland, where the ocean gets warm, it melts these ice masses from underneath and they start sliding. And another worrisome news is that the speed of ice mass loss to the oceans, increasing sea level to more than we have predicted in the last decades, is a threat to basically all of humanity. When you think that half of the 8 billions that we are live close to the coast, it is something that we have to prepare for, that we really have to move people fast out of critical zones, that we have rethink the way we build infrastructure on coasts, that we have to understand what coasts do for us and learn how to protect them. Some people speak of the immense complexity of the climate crisis as to say there's no chance we can solve that problem today. But when you think about it, when you read your science, then it becomes very clear it's just one factor. It's us, the humans, that use fossil fuel. The emission of CO2 that we have today brings us already within 7 years across the 1.5 degrees global warming boundary, close to the Paris climate goals, and probably even beyond that when we continue the way we work today. Then we must understand that emission of CO2 to the atmosphere is our greatest risk, and it's the one factor we need to get a handle on.
Thank you. Okay, please. So I now have the possibility of welcoming my panel. Thank you. Please join me. Thank you. Please do sit down, please. Hello. So some you have met before. You've met Newsha before, Novoselov you've met before. I have a great pleasure in introducing Fumio Inagaki from Tohoku University and Keiko, Fumio Inagaki from Tohoku University and Keiko Takahashi from Waseda University. Welcome to this panel. We've been hearing all day about the effects on water globally of climate change. Is there anything we've missed? Is there any aspect of the effect of climate change on water that we just need to add to the mix? Fumio, is there anything?
Yeah, first, I'm a professor at the Tohoku University, but I have long working on the deep sea and subsea for biosphere research at JAMSTEC, the Japan Agency for Marine Earth Science and Technology. And I completely agree with what that Antje had just mentioned, that the climate change is accelerating and a tangible threat for human sustainability. And I'm now feeling maybe the biggest concern caused by climate change will be the sea level rise, the consequence of sea level rise. Because, that Antje mentions the global warming is accelerating, and then we may expect a rapid dissolution of ice on the polar regions and Greenland ice sheet and the permafrost on land, for example. And then some people are expecting maybe the sea level rise is more than 4 meters or 3 meters. It is not just a few centimeters. It's serious because, and especially serious for the coastal area because over 40% of Earth's population is living in the coastal area, within the 100 kilometers. So it's a big problem. So we need to solve the issue.
And also the consequent effects on ecosystems that live in water.
Yes, right. Because this is not an issue of human cities. Of course, the resident is important, but also we need to scientifically understand what is the land to sea transport system, like a fresh water and the sea water interaction, and also ecosystem. So how ecosystem will change. So from the geoscience point of view, if the 4 meter, for example, if 4 meter sea level rise occurs, the large amount of coastal areas centered on river delta maybe became the shallow sea. Then what happened? Then what is the impact on biogeochemical cycles or agriculture? I expect an enormous impact, but it is not yet scientifically solved. So we need to explore it.
Thank you very much indeed. I don't know whether anyone else wants to throw in any other effects. Feel free if you do, but otherwise, Newsha, do you want to talk or you?
Yeah, I just wanted to add something to what Fumio said, which is what sea level rise is such an important issue. Another part of it is it's not just sea level is rising. We are experiencing more floods because of sea level rise. We are experiencing, our cities, urban as coastal cities are experiencing daytime flooding, which is, sunny day flooding, which is there's not raining, but the sea is rising and actually showing up in the streets. The setup that we have is really not well equipped to deal with a lot of these experiences we are having. And Antje mentioned that very eloquently, which is like, we really do need to go back and rethink and reimagine how we build in these cities and communities, that we rethink and reimagine the ones that we have. And we also need to seriously think how we are building the future cities, considering all these impacts of climate change.
Thank you, Newsha. So, Keiko, that reimagining depends very much on the ability to link our modeling of what we see happening on different scales, right?
So I am the major in the computation simulation for the prediction, and we consider about the very importance between the scale differences. So city scales is very important for the people, but not also that is very important things to the influence to the global. So that is between with balance of the scales is a very important thing. So that is same things in the water matters.
Fumio, you might want to comment on that also, this transition from the local to the global, or the human time scale to the, I mean, you're a geomicrobiologist, to the geologic time scale.
Oh, yeah. The local is, of course, very important because geological setting, cultural setting, socio-cultural element is also very important. Socio-cultural setting and climate settings all are different at local. But on the other hand, I think it is important to understand the global, the fundamental mechanisms of our system as a driver. So, for instance, the many people working on the, the tomorrow's sustainability, but on the other hand, if we don't have the, the fundamental mechanism understanding in the mid to long-term timescales, it is very difficult to, understand if the immediate action is correct or not. So both the short and the long time scale investigation is necessary, in my opinion.
A word that Antje used was transparency, and that's such an important word. We need to see where we're going. Sorry, Kostya, please.
Yeah, I think this transition between global and local is extremely important, and it's going to be even more important in the future. We need to realize that, in fact, we don't have global shortage of water, so the amount of water is still the same. With the climate change and global warming, what we're going to have is new redistribution and maybe more severe redistribution of water, and it will force us to invent new solutions for this. And unfortunately, every new solution doesn't come for free. We have to use energy for this, spend energy, and that just goes back into the climate change. So we've been talking this morning about desalination plants. The problem is that those desalination is extremely expensive in terms of energy. You basically trade your fresh water for your carbon credit. So we really have to think about how to get it without the use of extra energy, and without cost of the transportation. So local production of energy simultaneously with the local desalination is one possible way. Even better would be, and there are ways how to do it, getting energy from the ambient, getting energy from the evaporation of water as well. But then maybe there are technologies which allow you local water production without the use of electricity. You use the evaporation, you use algae, for example, and so this local production would be extremely important in the future.
That's such an important point to bring, the connection between water and energy. And I mean, Antje said the key is simply is decarbonization, and that's true. But water lies at the very heart of our efforts to decarbonize. And I see Newsha nodding there, so please.
Yes, I think I just wanted to touch on that because the interlinks between water, energy, and climate is quite real. And I think we are putting a lot of energy and resources in decarbonizing and reimagining our energy portfolio. However, there's very limited thought is going into what are the water and environmental footprint of that transition. For example, we talk about having batteries as a storage space that requires lithium. What does lithium require? Water. So that means that all of a sudden we are actually having we are transitioning from fossil fuel extraction to lithium extraction. We are changing one water-intensive process to another water-intensive process. And that is actually not going to solve our problem in a sense that because our demand is growing exponentially. So there is no way we can meet future demand the way we are going and be able to decarbonize and replace everything with renewables and not impact the environment in a negative way. So it's very important, I think, going back to the comment that was brought up on city scale and local scale, I think that is a building block of the society. So if we really want to have a long-term solution for climate, we actually need to start from the building block and figure out what is it we are doing that's not working and how can we change that? For example, I'm switching topic a little bit, but I think it's very important because it goes back to the comment I made earlier as well. In developed countries, we flush down toilet drinkable water, right? Or we use, in California, we use drinkable water to water our lawns. We are building new cities with high speed right now, especially in Global South. And a lot of those cities are being designed and built the same way that our cities in the developed world was designed and built. So not only we are decarbonizing and rethinking how to generate and use energy, we are also we are not doing that in the water side. So we are actually re-emphasizing the bad habits that we had on the water side as we are going from location to location. So for example, we are not looking at how people use water. We want to have more water, so we bring desalination to create water abundance without necessarily thinking how that impacts our long-term need.
Propagating, the current model, absolutely. Yes,
absolutely.
Thank you. Thank you very much indeed. I'd like to bring everyone in. Kostya, you did want to come in on this lithium battery.
I'm sorry that if I'm just keeping on and on this, and but I'd like to pick up the button from Newsha again. So this, and we this morning again we discussed exactly that we really need to descale the water production and just bring it closer to the to people on the local level, because it would really allow you to save a lot of energy on the water cleaning, on the water desalination. Talking about this story about the relation between energy and water. So we spend a huge amount of energy on creation of the fresh water. It's simply because the hydration energy of sodium, so which is really huge, hundreds of kilojoule per mole. So we have to provide this energy in order to withdraw water molecules from sodium. But then at the end of the day, we drank it, we flushed the toilet, and then this water ends up in sea again, releasing the same amount of energy. So just energy is not going anywhere. So maybe we need to learn how to use this. And in Japan, in Israel, in Singapore, most of our wastewater goes back into the ocean. So, and there are technologies which allows you to gain this energy back, which you previously spent on the desalination. And I think technologies like this, which allows you to dramatically reduce the energy consumption on the water production, especially locally, would be very important.
Thank you very much. Thank you. I'd like to bring Fumio and Keiko in. Fumio first.
Oh, yes. I think in order to prepare such a climate change in a short time scale, I think it is also important to understand the past ecosystem. Past is a key for eliminating the future, because we have already experienced, some climate changes. For example, roughly 55 million years ago, there was a global event of PETM, the Paleocene-Eocene summer maximum. At the time, Earth was pretty much warm. So the CO2 concentration is over 2,000 ppm, which is 5 times, the larger than the current CO2 concentration. And there is no ice in the Arctic area, but there is diverse ecosystem. And the temperature change will be 5 to 9 degrees C. Then the ecosystem responds to such changes. The temperature increase or decrease, then we can learn from the past how ecosystem adapted to those changes and evolved and established some new function of life. And then we can learn from them. Then how we can prepare it. So because the increasing speed, as Antje said, the temperature is increasing, rapidly increasing. So that
brings us very nicely onto the topic of resilience, which I wanted to address now. But Keiko, please.
All right. From a really different point of the view. So we'd like to take the simulation for the global warming and predictive warming and due to the waters. And but we have to thinking about the observations, very important things to predict over to control of the water. The temperature or in the seas and some kind of the energy from the to the seas. So that is a very important things to predict and observation in the global and local areas. So that we have to thinking about some kind of the lack of the observation point. So not only the satellite, but also our very fine observation point is a very important things to do. Create our very good activities.
Are you pleased with the progress in predictive models?
Yeah. So, and very important things to predict and promote of the model for the future's predictions.
Thank you very much. Okay, I'd like to turn, we don't have too long, but I'd like to turn to the topic of resilience and how we build resilience. I suppose let's ask, are we ready? Are we able to build resilience? Are we prepared? Newsha, do you want to go first? Are we well set up?
Oh, yes.
Sure.
Oh, well, lovely to have too many panelists wanting to answer a question. It's a moderator's dream. Thank you. Let's have Newsha first and then Fumio.
Sure. I would say we have all the tools, but we might not have the right institutional and policies in place to help us to sort of become more resilient. For example, I think the topic, again, going back to desalination, we use the same technology for desalination as we used for recycling. We actually talk about circular economy at every scale, on every commodity or topic that we are interested in. Think about plastics or anything. Circular economy is a big topic right now. But when it comes to water, people cannot really imagine how does that look like. But imagine your home would take the water from your shower, use it for flushing your toilets, or for example, in a building, you can capture all the waters that you can get and treat it and reuse it. And then that can actually scale up to the city scale, then the regional scale, and beyond that. So we can do this, but it requires willingness, it requires the right institutional setup, and requires local interest and capacity to do something like this. And another piece of this is also working in nature. I think Fumio brought up something very important. What we have learned in the cities we have right now is that they don't have enough flexibility in them. They're not resilient because they can't handle the changes they're experiencing. They can't adapt fast enough. And I think what we are trying to do is work with nature to create that flexibility, trying to create more green spaces, or this effort in China on sponge cities. They're all meant to kind of create that flexibility in our existing urban areas to work with nature and adapt faster and respond to the extremes we are experiencing in a more in a time scale that can be practical and help us to kind of be able to function in this new extremes, in a new sort of setup that we are in.
Thank you. Fumio.
Oh, yes. In upcoming decades, I think it is important for us to manage the CO2 reduction as well. I think we need to keep the effort on the CCS, the CO2 capture and sequestration. But on the other hand, of course, we need to secure the safe and innovative way, more innovative way to secure the safety and contribute to the CO2 reduction. But on the other hand, I think that circulation is important. And actually, we had a very good conversation with in this morning about the membrane and the electron transfer. So the microbes are brilliant. So some microbes can eat instead of hydrogen, the proton and electron directly and convert CO2 to methane or other useful fuels. This is so-called electromicrobiology or electrophilic microbes. And then that reaction occurs on a cathode. And what is the effective cathode materials? Maybe you can say something. We sometimes tested graphene. The graphene is brilliant material, I think. So such a technology development contribute to how that we can utilize a natural ecosystem effectively by human technology. So this is I'd like to add.
I can only. I mean, thank you so much for giving this, just feeding this line to me. I mean, it will require a full lecture on how you can basically grow your batteries from graphene polymers and bacteria, and it's a very exciting and very promising area. But just coming back to Adam's question, I'm not sure if we actually have got everything, because I mean, with my communist background, I don't believe in institutional approaches. So I'm actually much more excited about the previous talk by Paul and Newsha, and I think the economical approaches are by far more effective here. And it was really exciting to listen about so after carbon trading, so about water trading, but maybe we need to think a bit more globally and think about climate trading, because say if Bob is trading his water for or just consuming less water, trading it to Alice, then the local climate would be a little bit hotter. We have to switch our air conditioning a little bit more in the area where Bob is doing his agricultural activity. We just bring those air cons a bit down where Alice is doing this. So I think taking it into account and bringing it to a regular household that we actually feel responsible for the climate change would be an interesting solution.
Thank you very much indeed. Keiko, I must give the last word to you because we're out of time. So,
all right, okay. I'm feeling that some kind of the important things of the earth homeostasis. Some kind of the means the circulation of the life, and that is very important things. The energy and water and some kind of the CO2, and these things is a very the means that's the stock of nature. So that is a very important things to circulation. Meaning is a very important things for the earth, I think. That's
thank you very much indeed.
Okay.
Listening to nature seems to be one of the lessons. Before we started this, Fumio advised me not to get too pessimistic in this panel, and I think it's not been too bad. I think there's been tinges of hope in there as well, so that's nice. It's a good thing before our coffee break. So we're out of time, and just remains for me to thank all my panelists very much indeed. Thank you.